Well, hey guys, Doug here with your Week 9 MyStatLab Problem 10 example. So let's look at the problem. In a certain running event, preliminary heats are determined by random draw. So it would be expected that the abilities of runners in the various heats are about the same on average. The accompanying table shows the times in seconds for preliminary heats 2 and 5 in a particular year. Is there any evidence that the mean time to finish is different for randomized heats? Explain, be sure to include a discussion of assumptions and conditions for the analysis. Well, here is our table. We have heat 2 with the times, heat 5 also with their times. That's pretty much what we're talking about here now. So let's go ahead and look at our assumptions and conditions. The first one being the randomization condition. So the randomization condition is that the data in each group should be drawn independently and at random from the population of total runners. Well, it tells us that they are determined by random draw. So we would have to assume that that randomization condition is satisfied. The second condition, the independent groups assumption, is that the two groups being compared, which are heat 1, heat 2, and heat 5, must be independent from each other. The independent group's assumption is satisfied because here again these things are drawn at random. In our third condition, the nearly normal condition, we'll probably need to take a look at a few things and let's see what we come up with. Well, in the nearly normal condition, it says that sample sizes less than 15. The method of mean comparison should not be used if the histogram or the box plot show severe skewness. So we have two samples here. So let's go ahead and take a look. I've already made a box plot. Let's take a look at that. And I also have the histogram of each heat. So let's take a look at those also. So look at our box plots for heat 2 and heat 5. Pretty much gathered together here. Not much except for this one time way up here. Pretty much like an outlier, isn't it? But other than that, we look pretty good. Heat 2 here. There again, fairly normal, especially without that one outlier out there. Heat 5, of course, looks very much normal. So without the outlier, if we took the outlier out of both of these, then they would look pretty much normal and it'd be in pretty good shape there. So without those outliers, we would have to say that neither one of these, the box plot or our histograms, would be severely skewed, so we should be okay. So there are your conditions. They're all met. Now the next thing it asks us is to conduct a hypothesis test to test whether the mean time to finish is different for randomized heats. So for this, we would say our null hypothesis is that the two heats are not different. That the mean from heat 1 is equal to the mean to heat of heat 5. And of course, our alternate hypothesis would be is that the mean of the two are not equal to 0, that they are different. And we're going to use an alpha of 0.05. Now for this, let's go back to our stat crunch and take a look at that. And I've taken the data here and I've taken heat 2 and put it in its own column, heat 5, those numbers, and put it in a column to itself also, to make it a little bit easier when we get ready to do it. So let's go to our t-stats as we did in problem 4, 2 samples, with data. Column 5 is one heat. Column 6 is the other. We're going to do a hypothesis test at our 0.05 alpha or a 95% confidence level. And we'll store the data in a table. So all we have to do is compute. And here's our p-value up here, which is what we'll need. So let's take our p-value, copy it, and we'll paste it down here. So it's showing us a p-value of 0.199 and an alpha of 0.05. Well, if the p-value is less than our alpha, then we reject the null hypothesis. But in this case, our p-value is greater than alpha, so we do not reject the null hypothesis. So there you go. We've taken a look at our conditions, we looked at our charts for a box plot and our histograms of each heat. They look pretty normal other than that one outlier which we can throw out, which means everything seems to be okay. And we did a hypothesis test with an alpha of 0.05 using StatsCrunch, which is very easy to use to do this. And we come up with this p-value of 0.199 versus our alpha of 0.05. So we do not reject our null hypothesis, that they are basically the same. So there you have it. Week 9, MyStatLab Problem 10 example. We're done. See you next time.